To get into orbit around Mercury, MESSENGER must fly by the planet Mercury several times. This lengthens the mission, but it means that we get return of scientific data far before we get into orbit. We use those flybys to take energy out of the orbit of the spacecraft around the Sun so that we can eventually do an orbit insertion burn. And each time we fly by Mercury, the orbit of MESSENGER gets a little closer to the orbit of Mercury around the Sun. The very first flyby is in January of 2008, January 14th to be precise. The second flyby is a little, nearly 9 months later, in October 2008. The third flyby is 11 months after that, in September of 2009. And then the fourth encounter is 18 months after the third flyby. So those encounters are getting farther and farther apart because MESSENGER is matching its speed more closely to that of Mercury around the Sun, and so it takes longer to catch up each time. Each one of those flybys will have a broadly similar geometry with respect to the planet, although not with respect to longitude. The spacecraft will approach from the night side of the planet, so most of the planet will be in darkness. There'll be a crescent of lit material that we will focus on primarily to make sure that our navigation is spot on, so that we can make any correction as needed prior to the closest approach. The closest approach will be about 200 kilometers, about 120 miles, off the surface of Mercury for all three flybys. And then as we depart from the planet, we'll be looking back toward the planet. Most of it will be in daylight, and we'll be taking images, we'll be making image mosaics, we'll be making spectral measurements of the surface, we'll be looking at Mercury's atmosphere, trying to find new species. By flying as close as 200 kilometers to the surface, we'll be well inside Mercury's magnetosphere. We'll be making the highest resolution measurements yet made of Mercury's magnetic field. We'll see the major boundaries of the magnetosphere through the magnetic field and through the energetic and plasma spectrometer instrument. In terms of imaging, the first flyby will see almost half the planet. And one of the wonderful outcomes of this particular mission design is that about half of the part that we will see will be new, will be this gray area that Mariner 10 never saw. On top of that, the second flyby in October of 2008, we'll see the other half of Mercury. Almost precisely the opposite side of Mercury will be sunlit from the part we see this coming January. So by the time 2008 has ended, we will have imaged more than 90% of the surface of Mercury in a variety of resolutions in color, but some of those resolutions will be substantially better than Mariner 10. At each flyby, because of limitations on spacecraft pointing, because we're using the spacecraft to point a lot of our instruments, we won't have data from the flyby immediately. We'll be taking observations for something like 2 days on either side of closest approach. And it'll be 2 or 3 days after closest approach before the first data can be played.